Hello and welcome back, Monkhouse here. So the overall goal and the overarching goal of this video series is to be able to use graph cuts to do basic image segmentation. So separating an image into background and foreground, like we did in my other image segmentation video using thresholding. That's too much information, but that's okay. So before we can do that, we have to answer the question, how can we even implement a graph cut, a simple graph cut in Python? And that's what we're going to be trying to do in this video today. Now, if you're new to graph cuts, then I will also in this video be answering the question, what is a graph cut? It will be answered in a very high level manner, but we are going to be working through a super simple example, and then you should be able to kind of understand intuitively what it is we're going to be doing by the time we get to the image segmentation video. Now, if you personally have any questions, you can post them below, but also check the description first, because I will be putting some questions in there, and I'll also be answering some questions, some simple questions. You know, maybe there's some terminology you weren't familiar with or stuff like that. So check out the description and the questions, and yeah, if you still have a question, then post it below. So as always, do we need to install anything before we can start writing our code? And the answer is yes. We want to install three things. So even if you watched the previous video, we were using Python 2, and we want to switch to Python 3 because I was wrong. So, and I'll tell you why in a bit. But we're going to start by installing something called PyGraph. And what this is going to allow us to do, it will basically do the graph cutting for us once we give it a set of nodes. So that's going to be super quick, super useful, a couple lines of code. On top of that, we were using NetworkX. We want to use pip3 to install NetworkX this time. So you're going to have it for, see, I thought it was only on Python 2, but I was completely wrong. So do that. And then on top of that, we also want to make sure we've got matplotlib, of course, for our Python 3 version. So once we've done that, you can pause the video if it's going to take you a bit longer to download. Otherwise, we can just go ahead and get started now. So just one last thing I want to say before we start coding is that some of the code in this video is from a book, well, some of the segments of code is from a book called Programming Computer Vision with Python. So I will leave a link to that book in the description in case you want to check it out. So other than that, we can actually get started now. And what I'm going to do is open, hang on, what was it called? I think it was called test2, wasn't it? Yes, we're going to use Sublime. You can use whatever editor you want, of course, and we're going to open up our code that we had from the previous video. So once again, I lied to you. There's one last thing we need to install because I just tried executing my script and it didn't work. And I'll just get it up on the screen. And we need this for PyGraph to work. You want to do pip3 install Python graph core. Now, once we've done that, I believe everything will work. So everything is perfect now. So let's get started, for real. So if you've been following along in this series, the first thing we want to do is change this code to look like this. So we want to use the planar layout. And what that's going to do is make sure that there's no cross intersections, basically. It's just going to clean up our graph. And this is the reason we had to switch to the Python 3 version of NetworkX, because actually it didn't exist for Python 2. So that's why we've switched. And the other thing I want to do is we're going to change our nodes completely, but we're going to have the same number of nodes as this, I believe. So we're going to label these as numbers, and we're going to go from, I've got it on my left hand side screen here now, but we're going to go from 0 to 1, and then we're going to also go from 0 to node 2, then we're going to go from node 1 to node 2, and then we're also going to go from node 1 to node 3, and we're going to go from node 2 to node 3. Now it's probably quite hard for you to visualize this straight away, but essentially what we're trying to do, we've got a sort of, if we drew it on by pen, it would be a kind of diamond formation. So the first thing we can probably do is check that this is working. I keep forgetting, yeah, it's just Python. So we want to do Python 3 here, make sure you're doing that if you're on Linux. Python 3 test2.py. So that's kind of what we want. So we've got our node 0, and that's pointing to node 1 and to node 2, and then we've got node 1 pointing to node 2 and to node 3, and we've also got node 2 just pointing to node 3. So let's begin now by trying to build a simple graph It's going to have some edges as well. We're going to make a few changes to this code, and then I can actually talk about what a graph cut is. So I'll try and be quick here. So first thing we notice here is actually we're no longer using this terminology at all, and we're going to change that to 3, and we'll probably change these again. So we're going to make a few changes. Firstly, what we want is weights on our graph. So let's look at a graph and what it looked like. We can keep it up. So we've now changed it. So we've got this kind of 0 node, we've got this beginning node and this end node, and then these are just nodes within our network. I'll keep that up. We can ignore that though. Well, actually I won't. But we know that that's what we have currently. And again, if you didn't watch the customization video, all we did here is change the reference scales for the end value and the beginning value. Okay, so what do we want to do? Notice there was no edge values, so that's the first thing we want to do. We basically want to add some weights to our edges, and we can actually do this in a super simple way. And I think it's add. We just need to change this to weighted. So add weighted edges from, and then we've got our list of tuples, and then all we need to do is put in our values. Here I'm going to put 4. Now I'm basically simulating a graph from that book I mentioned at the beginning, programming, whatever it's called, I'm not sure. 3, and we want 3 again, and we want 4, and then finally we want 5. So this is going to be our directed graph. That's all of the weights and all of the node values. Although I think in a later video we'll be changing 0 and 3 to foreground and background when we do the image segmentation, but don't worry about that at all. So what else do we need to do? Let me have a look. I have the code here on my left hand side, just so I can remember what we need to do. So we aren't drawing the new weights yet. So the first thing we want to do, well, another thing we want to do is draw the network, and I think it's edge labels, yes, if I could spell. Edge labels, and G and pos as always, and then we've got this parameter called edge labels, and what we're going to have here is labels. I haven't defined labels yet, but I'm going to do that in just a moment. So the labels can be defined wherever we want. I'm probably going to put the labels here at the top just so we can see what's going on. So the labels are going to come from this this array. Now these are weights and they're stored as weight. So what we're going to do is we're going to, and you'll see what I mean in a moment. So we're going to do nx get edge attributes. Now I don't know what the documentation says about this. I could have a quick look for you. Edge attributes. Nothing came up. Let me just, I did want to see if there's nx.get edge attributes. Okay, for some reason that's not coming up at all. Maybe I've made a mistake. I don't think I have. So let's get back to what I was doing, and we're going to do our labels nx.get edge attributes, unless I've made a spelling mistake. Oh, this is the mistake. So this is probably what was going on. I'm probably going to be cutting all of this out. Okay, let me pull this through. Although this took a real long time to do, this is essentially the function that we're using, and we can essentially grab a network graph and we can find the attribute names depending on what we've defined them, and we can define our own attribute names. So we could do like color equals red, for example, and then we could get our labels that way. Now by default though, these are weight. So that's kind of where I was getting at, that's what I was trying to get at. So what are they now? So we want G, which is our graph, which is defined above, so that's okay. And we want weight. So this is just a string value. So I believe now that is everything. So we can just go ahead and test this now. And if we get an error, we get an error. So we didn't get an error, so this is great. So everything is working perfectly. Hopefully yours is working perfectly also. And oh, by the way, what you may notice is that these switch around sometimes, but fundamentally the graph is still the same because we just care about the direction and the values. So we've got 0 going to 1 and going to 2, and 1 going to 2, and 1 going to 3, and 2 going to 3. And here you've got our values. which are our edge values or edge weights, whichever you prefer, and these are our nodes, of course, you should know that, or vertices, or vertex in singular form. So that's we're in a really good place now. So what we can now do is try and answer the question of what actually is a graph cut and what is it aiming to achieve. So I have to come back now to that initial question we asked at the beginning of the video, which is how can we use a graph cut for image segmentation, and then we can explain it a little bit. So we can imagine we've got an image, and that image it's a simple image. Let's just say it's a plain background, maybe just a person in a desert or a person in a field, something like that. Now we could easily say that the person in the foreground is what we want to segment, and yeah, that's the foreground, and then the rest of it is the background. So then we can imagine, maybe I'm overcomplicating this for a minute, but we can imagine all of the nodes in our graph represent the pixels of the image. Now on top of that, we actually need to connect those to the foreground and the background in some form or other, which is what these are going to represent. So I might actually change these quickly to background and foreground just to show you what I mean. So stay with me, I don't want you to get confused or anything. So where was 0? Hang on, let me just, because it doesn't matter too much, but we'll say that 0 is the foreground. So we might make that F, and then anything which is 3 is the background. So if we go ahead, and we should change these also, so F, and B. So hopefully I think I clicked save. I did not click save, because otherwise that would have worked. So there you go. So now we've got our foreground and our background, and all of these nodes basically represent pixels. And what we're trying to do is we're trying to cut the graph literally in a way that separates the foreground from the background. So that's fundamentally what we're trying to achieve with this whole series. Now in relation to what we're doing here, we need to do a little bit of theory, but only a little bit, and we're trying to find basically the optimal way in which we can cut this graph. So then our next question is, well, how do we define what the optimal way is to cut a graph? And we're not going to go too deep into it, but essentially what we want to do is get the maximum possible flow through a graph. So let's explain that in a second. So this might be too difficult to explain with just a simple graph like this and no drawing or anything, but I'm going to give it a go anyway, and hopefully you can stick with me. If not, I'll put some links in the description so you can kind of read up about how this works a bit more, because I just want to focus on the practical side. Right, so we've got a beginning of the graph, which is going to be a foreground, and then we can basically imagine these as, the way I've had it explained to me is, think of these as water pipes, and here you've got like this infinite supply of water. Now how much water can go through here, and we'll just call it 3 units of water, or gallons, whatever you prefer. And this way we can have 4 gallons of water, right? So that's the maximum. So the maximum amount of water we're going to have at node 2 is 3, and the maximum amount of water we're going to have at node 1 is 4. Now we basically want to say, what's the maximum amount of water we can get to B, which is our background. And the way we can do that is we can have 4 go this way, and we can notice we can have 4 go this way also. So that's the maximum anyway, right? There's no more, we can't get more than 4 water this way. Now what about this way? We can get 3 here, but we can get 5 through here. But actually 4 water's going this way, so we've got no water going this way. We've got 3 going this way, and we can only get 3 to B. So actually the maximum amount of water in this case is exactly the same as the maximum coming into the system, which is 7. We've got 3 that can go through here, and 4 that can go through here. Now this has capacity of 5, which means we could put 2 more gallons of water through here, but we've got nowhere where this water's coming from. Now, if this number here was 5, for example, then we would have 5 going through here, 4 would go through here, we could put 1 through here, through here, and then you'd have 3 plus 1, 4 going through here. So you could do that. Alternatively, what we could do with this particular network is we start again at our foreground, our beginning point, and we go 4 this way, and so 3 gallons here, 4 gallons here, But rather than putting 4 through here, let's just say we put 2 gallons through here, and we put 2 gallons through here. So we've got 2 on this side, we've got 2 in the middle, meeting at node 2 with the 3, and then you've got 5 going through here. Hopefully I'm not complicating that too much, because you know it's quite hard to see what's going on when I'm just using words. Hopefully you can see what I'm trying to do though. So basically what we're trying to then say is, what's the in any given network, which will be way more complex, what's the maximum amount of water that can actually pass through here? So that's what we're trying to achieve. Now there's a bit of theory to this. This is basically called the... God, I've forgotten it now, so give me 2 seconds. I don't think I have it saved here, but there's a word for it. So we've got the min cut, or maximum, the max flow. That's what we call it. So the maximum flow, then there's a theory saying the maximum flow is equivalent to the minimum cut. So the minimum cut is how we want to cut the graph to split it into 2. Now, we've already established then that the maximum flow through this network is 7. And now what we essentially have to try and do is find a collection of edges. So these things are edges, which add up to 7, and that's where we're going to cut the graph. So I hope you understand that, and I'll show you again. So our flow through here is 4, 4, and then 3. It has a capacity of 5, but we can only get 3 here, so we've got a flow of 7. Okay, so we know that the maximum flow is 7, which tells us there's a way in which we can cut this particular graph so that we cut through a collection of edges which also add up to 7. So that's the theory. The minimum cut is equal in the quantity, integer quantity, to the maximum flow, which is 7. And we say, look, here is a collection of edges which would split the foreground from the background, which is what we're trying to do. So we drew a line through here, so that is the optimal way to split up this network. So basically we would say that F is our foreground, of course, and then the rest is attached to our background. So that's what we're saying. So we'd split it right across here. So hopefully I haven't overcomplicated that. If you have any questions, please leave them below. Seriously, I will try my best to answer them. I also have some questions in the description. So let's actually write some more code. Right, I'm really going to try and speed through this next bit, so I'm actually going to go ahead and copy and paste some of my own code across. So what we can do is we want to import digraph, or dgraph, directional graph, whatever you want to call it. And again, this particular bit of code now, this segment here, is from the book, which I've referenced a couple of times. So we're importing a couple of things, and we're using a directional graph again, but it's not the same one. So that didn't quite work how I wanted it to work. So WT4 brackets. Okay, let's do X here, X here, X here, and X here, and we can get rid of this. So what we're essentially doing though here is we're just creating the same network we've created before, except this is our nodes. If we want, we should probably change, just to keep everything consistent, I think we should be able to change these to normal letters. Now I'm not sure if we can, but I'm going to give it a go. So we needed to change everything which is a 0 essentially needs to be F, and everything which is a 3 needs to be B. Flow cuts, and then essentially here we're saying we're cutting F, which is the foreground, and the background. I hope I'm not confusing you too much. Maybe it's too early in the series for talking about this, but it's just foreground and background. And then this is clearly using Python 2, so that's not going to work. So that is the end of that statement, like so. Now I'm going to go ahead and try to run this program. I don't know if it's going to work. We might have to just undo everything I did. Okay, so actually it's quite happy with everything except for the fact that we've got flow is, and it's because it's not inside a string. End of line, literal. What have I done wrong here? Okay. So it's actually worked. So we've got our figure, and then what we've got here is our flow, and it's basically what we spoke about before. So we've got from F to 1, we've got a flow of 4. From F to 2, we've got a flow of 3. From 1 to 2, we've got a flow of 0, remember. We've got a flow of 0 because this is not the path to go. We're going to go this way instead. And then we've got from 1 to B, which is a flow of 4, and from 2 to B, which is 3, because again, we're only getting 3 into this node. So hopefully that makes sense. And then we can look at the cut. This is how we're actually segmenting now the graph. And what we're saying is that the nodes, so the node F belongs to 0, which is basically saying that's one cut, it's binary, and everything else belongs to, so node 1 and node 2 and node B all belong to the other part of the graph because they have 1, right? We're splitting into 2, so it's just binary. So 0 is this side and 1 is this other side. So that's basically how we do it. So we've just done a graph cut. Now that's pretty much, I think for today's video actually that's going to be it, because we've done everything we wanted to do. Hopefully you've actually learnt something and now you understand what we're trying to do in this image segmentation problem and how it can be theoretically possible. And then the idea, of course, is, I'm probably explaining too much because we're going to go ahead and do that more in image in the segmentation video, but what we want to, the only thing we'd really have left to define is, well, what are these edge values going to be? How are we going to determine them? We're going to essentially have a grid of pixels, and we might say, well, what's the difference between the pixels and values? Large numbers mean the pixels are really different, small numbers mean the pixels are quite similar. Alternatively, you could have like an average of the pixels around you. So there's lots of ways, and we'll also need to do an initial like classification type thing where we categorize all pixels. We give all pixels basically a probability of being more likely to be background or foreground, and then we've got a graph to work with. So that's what we're doing. It's really cool, really exciting, and hopefully this video was useful. Again, I don't mind if you don't have to leave a like or even subscribe, but if you have a question, then I really recommend asking. Someone will probably help you, maybe even me. So again, thank you for watching, and I will see you in the next video.